Today's lesson is about graphing inequalities and solving systems of inequalities using a graph. So remember that an inequality gives us a range of possible answers. So unlike equations where we find a single answer, inequalities have lots of answers that can work for our problem. So there's several steps that we're going to follow in order to graph these inequalities and figure out what our range of answers is. So let me write those down for you. First, we're going to figure out what our boundary for the inequality is by pretending that that inequality that you see, pretend it's a line. So you're going to make it look like y equals mx plus b, except that it'll be a greater than or a less than sign. So turn it into slope-intercept form. Then you're going to make a t-chart, just like you do when you're solving a real line or graphing a real line, to find points on that line. Now remember that when we graph these inequalities, just like when we're graphing equations, y equals mx plus b, the y is on the left-hand side, and so for the purposes of graphing these inequalities, you want to do the same thing. Make sure when you're doing them that your y is on the left-hand side. So reading it in terms of y, if you have a greater than or a greater than and equal to, you're going to shade above the line. All your answers will be above the line. If you have a less than or less than and equal to, you're going to shade below. And these statements are only true as long as y is on the left-hand side. So make sure y is on the left. Otherwise, this will all be backwards. Now, when you're making that line, the other thing that you need to keep in mind is that if it's greater than or less than, you have a dashed line. So it gets written like, instead of being solid, it's dashed. And what that means is that your answers don't actually fall on the line. They're strictly above or strictly below. If you have an equals to underneath, then it's a solid line. And that means that your answers are above and also on the line, or below and also on the line. So let's try graphing a few. So, the first thing we want to do is make sure that we make it look like slope-intercept form. So we need to get the y alone. We're going to start by subtracting 5x from both sides. Then we're going to divide by -4. Remember that our rules of inequalities still apply, so when you multiply or divide by a negative, it changes the direction of the inequality. And we're going to reduce that, divide by 2 on top and bottom. Okay, now that you have this set up, you're going to make a t-chart. And you're going to choose any values that you want for x. Generally speaking, starting with 0 is a good place to start because it makes it sort of easy, because it'll cancel out some stuff. So I'll choose x to be 0. That makes that gone. And you're left with -5/2, which is the same as -2.5. Then the next point I'm going to choose, multiples of 4 are going to be the easiest because they're going to cancel out the denominator. So if I make x 4, then I'm left with 5, take away 2.5, which is positive 2.5. And now I have my 2 points that I need for graphing. Okay, you're going to use graph paper to do this assignment, so for right now, just bear with me. 0, -2.5 is going to go down 2.5 boxes on the y-axis. And then positive 4, 2.5. Is going to go over 4 and up 2.5, and you're going to connect it as best you can. Because this is strictly a less than sign, it means that my line is dashed. So you can go back through and make it dashed, or you can try drawing it dashed as you go about it. And it's less than, so that means I'm going to shade below the line. So my answers fall in this range. Any point that I choose down here, if I plug it back into my inequality, it's going to give me a true statement, something like 10 is bigger than 2. If I choose a point up here, or on the line itself, it's going to give me a false statement. So it's going to be something like 1 is greater than 3, something that you know is truly wrong. So these are all answers that will work. Let's try another. So this one looks a little bit simpler, but sometimes people have a hard time figuring out what to do when there's only one variable. First of all, we don't have to get it into y equals mx plus b form because it already is. The y is already alone. So we go ahead and make a t-chart. And remember that we're pretending that this is an equal sign in order to figure out what the boundary line is going to be. So what this really says is y is 3. No matter what you choose for x, y is going to be 3. So 0, 3. 1, 3, I can keep going, 2, 3, 10, 3, 103, and graph it. 0, 3, 1, 3. This is going to be a solid line, and it's a horizontal line. And this tells me to shade above, because it's greater than. So all my answers are going to be above this line. And that makes sense, because if y is bigger than 3, everything that's bigger than 3 for y is up here, not down here. Let's see what happens when we have only x's. So we can't get it into y equals mx plus b form, again, because we don't have a y. So we just go ahead and make a t-chart. And this is doing the reverse of what the previous example was doing. So instead it's saying no matter what you choose for y, x is going to be negative 2. So negative 2, 0, negative 2, 1, we could keep going. And we graph it. And it makes a vertical line, which is dashed. Now you might notice that our rules don't really apply here. You can't shade above or below a vertical line. But you kind of go with what makes sense. If x is smaller than, it's less than negative 2, then we're going to shade points that are on the left. If it's bigger than negative 2, greater than, we would shade right. So you have to use a little bit of common sense on this one. So all the answers that work for this inequality fall in this range on this side of the graph. Now that we've looked a little bit about graphing a single line, the other thing we need to figure out is what happens when you have two inequalities and you're trying to figure out a range that works for both of them. That's called solving a system of inequalities. So let's try one of those. Really what this amounts to is just doing two problems and putting it on the same graph. So we're going to start on this side. We're going to get y alone, just like we did before. Subtract x. Y is less than or equal to negative x plus 6. You're going to make a t-chart and get 2 points. So 0, if I plug in 0, that gives me 6. 1, negative 1 plus 6 is 5. So I've got 2 points, and I can go ahead and put those on my graph. And this is going to be a solid line. And I'm going to shade below. So that's that half of the problem. Now I do the same thing with the other half, and I'm going to change colors because I want to be able to see what's really going on where the two colors overlap. So to get y alone over here, I'm going to divide by 2. So y is greater than 1/2 x. Now I'm going to set up a t-chart. Choose a value for x, like 0. That makes that 0. And then go for multiples of 2, because that'll help cancel out the fraction. So if I choose 2, the 2's cancel, and y is 1. So on my same graph, 0, 0, 2, 1, this is going to be a dashed line. So make sure you dash it. And I'm going to shade above. Now the answers, you can see that there's a blue area that would solve the blue equation. There's a red area that would give me answers that would work for the red equation. The answers that really work for me, though, are the ones that satisfy both of those inequalities. And that's going to happen in this triangular region where the two colors overlap. So what that means is, going on indefinitely, anything I choose in this area will make both this and this true. And if I choose something over here in the white, it'll make neither of them true. And then you can see that there's a blue area and a red area, which will satisfy one but not the other. So now that you've seen a few examples, I think you're ready to try some problems graphing inequalities and solving systems of inequalities.